And now we are going to start the system development life cycle. That is a grade 11 second lesson. So earlier, the first lesson we learn about the programming part. So in that part, we learn about the two stages in the software development. So in that case, we learn about the designing and the coding part. So in this lesson, we cover all the development life cycle. First, we have to learn what is a system. A system is a collection of components that interact to achieve a specific task. So we'll say every system has a components. These components are interact to achieve some goal. We'll say a car. There is several components work together to achieve their goal. Like that is goal is the task is to transportation. Okay. So that in that case, uh, this system, the car system, has several components like an engine. There is a wiper. There is a gearbox, and there are many components work together to do that specific task. So every system has an input, process, and the output. So we'll say like that the system is a collection of components to work together to achieve that some goal. So in that case, to achieve that goal, there is a input, process, and the output. Output is the goal. Okay. Here we can have like this: the input, process, and the output. So we'll take the vehicle as a system. There is a input, fuel, and you need to have a key to start the vehicle. So process to start the car using the key. You have to put the car key into the key into the vehicle, and you can start the vehicle. Then you have to change the gear, and then you have to accelerate. That is the process of to move the car. So the process is start the vehicle, then you have to change the gear, and you can accelerate it. So we'll say, so earlier there are many systems like not only the vehicle, they are everything. If they are having a input, process, and output, we call it a system like a fan. You do have TV, television, radio. Those everything's a system, but you have to verify what are the input, what are the process, and what are the output. Every system has a specific goal to achieve that. Okay, that is the main definition of the system. So in that case, we are moving to the information system. That is, information system is the basic components and the basic goal or basic task is to provide the information. Okay, the provide the information. So providing the information, they need to have a input the data. Okay, so the information system, all components are work together to provide the information. Okay, so it take the data as input, and those data that convert into the information, that is the information system. Okay, so we have two types of information system, that is a manual system and the computer based system. Manual based, the most of the input processes and output done by the manual or the human, like a school attendance system. The teacher take the attendance of the student, and he or she mark the register, and he count the how many students are absent, how many students are attend, and she or he or teacher can calculate those things. So that is the manual system. All things like a input, process, and output done by the manually. For the computer-based system, the most of the things like input or the process or the output, the most of the things are done by the computer. Okay. These type of system uses computer power to process and generate the output like a fingerprint scanner. So that is also the um, fingerprint scanner also the using to mark the attendance, but not like a manual system. This computer-based system, it take the thumbprint to the as input, and it process and it mark the attendance of the whatever the employees or the students. That is a computer-based system. All things done by the computer power. So if we are taking the differences of the manual system and the computer-based system, like here the first one, errors are minimal with the data processed by the computer program. Errors are minimal. That means these computer-based information system, the data or the informations are very accurate. It are accurate. The correct output we can get. But the manual system, there are many errors because they're all things done by the humans. Data can be processed more efficiently because the computer-based systems are very speedy than the manual system. Large amount of data can be stored in a small physical surface. Database software can be used for the purpose. Like you can have a database, you can have a hard disk, you can have a memory stick or the flash drive or whatever the SD card you can have to store the data. But if you are using the manual storage system like files or cupboards, we do have a large space to store the data. So the computer-based system, they need to have a small space to store those data. Security can be ensured with the backups and use of password. That is most important thing in this category, the computer-based systems, because the every data should have a security. Okay? If you are using the manual system, we do have we can lock the cupboards or we can put the padlocks to the cupboards, but the computer-based system, you can have a heavy password, and you can have like a backups. You can put those backups into the safe places, like, or you can upload into the cloud. Like there are many security things you can have in this computer-based information system. Or you can, when you are transforming the data or the information, you can encrypt those things also. But the manual system, you can't do these things uh, like a computer-based information system. Okay. Now we learn about the what is a system, and we learn about the every system need to have a input, process, and output. So then we learn about the information system, that is the system that provide the information through the data. Uh, and we learn about the two types of the information system, that is a manual system and the computer-based system. So then we know about the differences between the computer-based system and the manual system. Okay. Now these are the basic thing of the systems. Okay. Now we are moving to the system development life cycle. So that means if you are developing or if you are making some system, you do have some steps to follow. That's we are going to learn, that is from these life cycles. So we have to follow these steps. First one is the identification of the requirements, feasibility study, designing of the system, coding of the system, testing of the system, deployment of the system, and the maintenance of the system. Okay. These are the 7 major stages to develop the system, computer-based system. So first thing, identification of the requirements. So in that part, before we are developing the system or we are making the system, we have to get the requirements from the user. In from the requirements, we can have a idea about what is the system, what are the requirements, what are the specifications of the system. Like the user can't understand what their requirements, so we have to go for the another method to get the requirements from the user. So there are many methods to gather the information that is called the fact finding methods. So we do have the 5 fact finding methods. First one, observation. Second one, interviews, questionnaires, document sample collection, and prototype. So we are going to learn those fact finding methods individually. Observation. So some of the users can't express their requirements because some of the users can't they don't have any uh, uh, idea about the IT or idea about their requirements like that. So the user or the system analyzer have to observe their places, or they have to visit their place, or and they have to inspect those things to gather the information. So what they're doing is observation means they have to visit their place, the analyzer have to visit their place and gather information, the gather requirements of the system. Okay? We'll say in the library, uh, when you're getting the requirements from the library, you have to go to the library and you have to collect what are the operations they are doing. So that is the observation. There you have to go, the analyzer have to go to the place and take the requirements and write it in the document. That is the observation. Interviews. Okay. Interviews mean that is a face-to-face discussion. User and the analyzer. Analyzer can ask the question from the user. The user have to answer them. That is the from the interviews, or from the interviews they can identify the requirements of the system. They can the analyzer also uh, explain what are the things they can do, what are the new things they have to input to the system, and the user also have some new ideas about the system. They can embed those things to the new system. That is the interview. That is a face-to-face discussion. Okay. The next one is a questionnaires. Questionnaires is that is also the fact-finding method. The questionnaire is the analyzer can give some question paper to the user to answer to take the requirements of the system. So some users doesn't like to have interviews or doesn't like to have a observation part. So they can use this method to give the data, to give the requirements to the user. Okay. So from this part, user can write anything about the requirement, their needs to the about the system what they developing. The next one is document sample collection. So this is all the analyzing part to the taking the data, to taking the requirements. Document sample collection. So that means the most of the users, analyzers can take the early documents like profit loss reports, dairy reports. They can inspect those reports and take the data, take the requirements. So in that reports, they can identify what are the requirements, what are the reports they need. Okay, like that. So from that, these reports can include to the uh, system development, new system development. Prototyping. Prototyping also another fact-finding method. So analyzer can display their early works, early systems to the user and take the requirements or take their needs of the system and identify and they write down in the document to develop that system. Okay, so prototyping means it display or display the early works, early projects to the user and take the requirements from the user. Feasibility study. Okay, the feasibility report. That is the second part. When you're analyzing the requirements, when you're analyzing the requirements, the needs of the system, we have to identify the feasibility report. We have to get the feasibility report. Feasibility means if we have to evaluate whether the system can be done by the user, because there are many things they have to do in this system. Like the user have to invest for the system. They have to take the new operational customers. They have to buy a new technical things like computers, printers. Also, we have to find whether they can do these things. Okay. So feasibility report is like that. So that means feasibility study, this proposed system is evaluated for the feasibility. Okay. So that means we have to, the developer have to identify these feasibilities before developing that one. Okay. So there are three types of feasibilities. Economical, that means user can invest money for this system. That is economical thing. Operational feasibility. That means user have any employees to operate this system, or they have to hire new employees. Technical. Technical means whether they have any technical things like a computers or the scanners or the printers to install this system, or we have to propose to buy new computers or technical things uh, and to install the system. Designing the solution. So we learn two things, that is the identification of the system, then we are learn about the feasibility study. So we are moving to the designing the solution. Designing the solution. So in the designing the part, we do have several designing stages. So early we take the requirements and we evaluate those things, whether they can invest the money for the system. Then from the analyzing part, we are now design the system. We do have the several designing stages. Early we do have the flow charts, designing part, and we have some other things like a ER diagrams, those things we have to design before code in the system. Because everything we have to document it. Okay. So when you are designing the system, we can directly convert those designs into the coding part, or we can translate those logical patterns to the physical pattern. So designing stages, we do have the several designing like a flow chart. We do have the ER diagrams. We do have the DFD diagrams, and like there are also the testing diagrams. Like we have several designing patterns. Then we are going to the code in the system. So when you are designing the system, we can directly convert those things into the physical part. So convert those things to the physical part, we are using some computer programming languages like a Pascal. We do have the several languages like a Python, a Java, we are having a PHP, those things we can use any type of the programming language to convert those logical designs to the physical coding system. Testing and debugging. So after the coding system, we are using to test the system. So we have to ensure that the whole code is running perfectly. So in that case, we have to have 4 stages to testing the system. First thing, unit testing. Unit testing is we are testing only the small unit. Like if you are taking the whole system has like a student, we say student management system. So we have the logging screen. We are having a student entering screen, and we do have the student uh, uh, enroll to the class system. Like there are many components. So we have to test each and every component separately. Like login screen, when you input the username, input the password, and when you click on the OK button, it will the, work perfectly and move to the next screen. That is the unit test. We have to test the separate unit that worked perfectly. Integrated testing. So that means we are done the unit testing. That means the small unit you have to test. Then we are integrate with another unit and test whether it's whether it's working perfectly. Like when I input the username and password, when you click on the OK button, then it should pass the user ID into the student details. So that means these two units are working perfectly. That is the integration testing. So integration means like these, you can see this picture, the small units are integrated and tested. That is the integration testing. System testing. So when you integrate the whole, the several units, then we can build a whole system. Then what we have to do is we have to test the whole system at once. Earlier we are test the separate units and we have to integrate with each other. Then after that it the whole system have to test with the inputs and the outputs. Okay, so we can test these output. We can take these outputs with and check whether it is correct or not. That is the system testing. Acceptance testing. Acceptance testing means these testing stage done by the user, whether this system accept by the user. Okay. We are take the requirements in the first stage, then we are designing, we take the feasibility report, then we are designing, then we are coding, then in the testing stage, we give, we show our developing system to the user and take the feedback. If they not satisfied in this stage, we have to build this system again. Or we have to modify those components. That is the acceptance testing. That means whether this system accepted by the user. Is the acceptance testing. After the testing part, we have to install the system in the user site. That is, we call the deployment of the system. Okay. Deployment. We do have this 4 types of deployments: direct, parallel, pilot, and phase. Direct means we remove or we uninstall the old system, the existing system, and we install the new system without having the existing system. Totally, we have to remove these things because that is the direct deployment. That is mostly this direct deployment done in the manual system, because the manual system, all things are terminated and we have to move to the computerized system. That is the direct deployment system. Uh, uh, Totally they terminate this existing system, then they install the new system and work with the new system. That is a direct deployment. Directly move to the new one. Parallel system, parallel deployment. The both existing and the new system work together, and they can find whether there is any errors in the new system, whether the new system outputs are whether correct with the old system outputs. That is a parallel deployment. The both should have to run together and find the outputs. That is a parallel deployment. Pilot deployment. That means you can install your new system in a selected area or selected departments. Like if you're having a department in a company has in a several departments like HR, IT, marketing, accounts. So first we are install the new system in the marketing department. If it is working perfectly, then we can move to the other departments. That is the pilot deployment. A pilot deployment. The first we have to, the whole system we are installed in the selected department or the selected area. So that is the pilot deployment. Phase deployment. Phase is like phase by phase, like stages. We can have several versions. We are not developing the whole system at once. Okay, or we are not install the whole system at once. What we have to do is we are install the system or the one of the version and check whether it is working or not. So if they are working perfectly, we can have a new version, the new version, and check like a stages, not the whole system. We are install stage by stage. That is a phase by phase. That we call the phase deployment. Maintenance of the system. That is the last part of the software development lifecycle, because early, the first part, we are gather the information, we gather the requirements, then we are take the feasibility report, then we are designing the system, then we code the system, that is the physical output of the system. Then after the coding, we have to test whether there is any errors or not. And if there is errors, we have to We have to correct those things. We have to debug those things. Then we can install the system. Then we have to maintain part. After the installing part, we can maintain. Maintains mean until end of the system, or we call the death of the system. We have to maintain part. We can have add in a new requirements. We can employ. We can embed new technology to the new system. So we can have a new troubleshoot the new system. So those things we have to uh, belongs to the maintenance of the system. So these are the 7 stages of the system. These are the 7 stages of the system development life cycle. Okay. So now we are moving to the system development life cycle models. So model means there are many type of model in the world. Many of the developers they have to they can use they can choose what the suitable one. There are many SDL models like waterfall, iterative, incremental model, agile models like that. There are many development models. The developer can choose what are the suitable for their project. That is the uh, uh, software development models. So we have the 2 types of models like a waterfall model and iterative and incremental model. Waterfall model. Actually, these are also called as a linear development model because it's like a waterfall. Starting from the top and stage by stage, it comes to the down like this. So we have identification of the requirements, then planning the solution, implementation, testing and debugging, deployment, and maintenance. So you can see these things. You can see these things like a waterfall. Like a waterfall. That means you have to complete each stage before start the new one. If you are complete the identification of the requirement, then you can start the planning. Like every stage you have to finish before start the new stage. That is we call the waterfall model. Waterfall model. Here, complete one stage before going to the next phase. Less user involvement. This is the most disadvantage of the waterfall model. Because uh, if if the developer or if the analyzer take the requirement from the user then meets at the acceptance testing stage. So they don't know how to code the system. They don't see the code. They don't see the what they're doing, what the developer doing, what the designing is, what the testing part is, and only they can see the acceptance part. So that means the waterfall has less involvement. You less user involvement. This actually is suitable for small system because large system is not using because uh, this is very less user involved. Okay, that's why they don't use the waterfall models for the large systems. So iterative and increment model here, identification of the requirements here. Then here the planning part. Then analyzing and designing, that is taking the requirements from the user and the user and the designing part. Then implement it. Again, testing the part. You can implement the use system or they can test it. Here, there is a new one, evaluation. Actually, this evaluation done by the user. If user not accept or not satisfied with this new system, they can take the planning part again and analyze again and testing, and again they can show to the user. So these are the iterative and increment model. Not these model not actually develop the whole system at once, like a waterfall model. Each and every stage have to show to the user and take the feedback and again increment it. So that is this is actually suitable for the large systems because there is a high user involvement. The last system, the final system may be the user that is already completed with the user's requirement. So that is the major part of the iterative and the incremental model. So these are the characteristics. System is developed through the repeated cycles, right? It's iterative. So user can view his or her system several times and give feedback of the system. So that is early we discussed about that. Every iterations, every cycles can view by the user, and the user can give the feedback to develop the system. System can start with a simple implementation. The developer can develop the small one and uh, view to the user and take the feedback and improve it. So that is actually suitable for the large system. These are the things we have in this second lesson, like software development lifecycle. You do have models also, waterfall model and iterative model. So we have to learn about these things. Summarizely, we can take what is a system. We do have the input, process, and the output in the system. We have the information system, that is the computerized system and the manual system. We learn about the differences of the system, and we are moving to the software development life cycle. We have the 7 stages. We learned 7 stages: identification of the requirements, feasibility study, designing, coding, testing, deployment, and maintenance. We learn about the models, that is waterfall model and the iterative and incremental model. Those are the things in the second lesson. Thank you. May God bless.